Hello class, my name is Jesse Armstrong and I am a technological design teacher candidate. I've been working here in Windsor locally over the past 24 years in the tool and die trade. I've designed dies for heavy stamping, fixtures, gauges, and machinery over the past 22 years. First, I'd like to say congratulations to the second years for almost completion of the program that you're in, and I hope to be where you are in a year from now. So far, it's been very challenging, but also rewarding. I've noticed how calm and confident you guys are when you're speaking, and I hope that I can get to that point when I'm in my second year as well. So this is my introduction to my lesson plan. My lesson plan today will be to have my students design a trapezoid in a CAD software. I'll be using SolidWorks, and we will first discuss the elements and the geometric elements of a trapezoid, and then we will go through. I will give an example of how it's designed, and I will create a print and also a sketch of a trapezoid, and the students will follow the print dimensions and create the same exact trapezoid. Introduction. The lesson will create an understanding of what the characteristics of trapezoids are and how to sketch a trapezoid. The lesson is based on the curriculum expectations of Grade 10 Open Task 20, 2024. The assessment will be derived from students' abilities to sketch a trapezoid using the metric system. The learning outcomes are based on good understanding of how to sketch a trapezoid in metric units. The lesson will be conducted in a safe manner, practicing proper ergonomics and a clean workspace. Expectations by strand. I chose this activity to show how a simple sketch can span over many expectation strands. These are some examples of the Grade 10 task curriculum expectation strands that were referenced during this lesson plan. See, in just creating a simple sketch of a trapezoid, we can cover initiating and planning, designing and performing, analyzing and refining, applying health and safety principles, fundamentals of technological development, impacts of technology, and careers and pathways in technology and skilled trades. A trapezoid is a quadrilateral that has at least one pair of parallel sides. A quadrilateral is a four-sided polygon having four edges or sides and four corners. And a polygon is a two-dimensional figure made up of line segments connected to form a closed polygonal chain. So in the first illustration of the trapezoid, you can see there are two parallel lines and two lines that are not parallel. The quadrilateral in this illustration shows two parallel lines, but there doesn't have to be, as long as it has four lines and four corners. And the polygon can have as many lines as it wants, as long as it's connected to form a closed polygonal chain. So if we look at this illustration of a trapezoid, we see that line segment AB and DC are parallel, and line segment AD and BC are not parallel. So as long as this geometric shape has one pair of parallel sides, it is a trapezoid. Uses for trapezoids. Trapezoids are often used in architectural and civil engineering applications. Bridges, roofs, and dams use trapezoidal cross sections and supports for structural stability and controlled water drainage. In infrastructure, the trapezoidal shape is often used in canals and highway drainage ditches. Frequently have trapezoidal cross sections to manage water flow efficiently. Isosceles trapezoids are a standardized shape for secondary highway warning signs. Even in the building and construction of furniture, trapezoids are often used, and household common items. For example, a bowl. If you look at a bowl, the front shape, you can see that the top is parallel to the bottom and the two side angles. It's a perfect trapezoid. It's symmetrical. Even a common popcorn dish, if you look at it, the top and the bottom are parallel, two side angled walls, creating a trapezoid. If you look at the front view of this bench or stool, you can see that the legs are on angles to each other, but the top and the bottom are parallel. This design actually creates support and strength, having these two angles going up to a flat top and a flat bottom. With the two parallel top and bottom, it creates strength and support and rigidity. Now we're going to go over to our CAD workstation. I'll be using SolidWorks to do this presentation. And I just want to first note that I'm sitting in a good ergonomic posture. And when I do long sessions of designing, I take breaks and I stretch and I rest my eyes. I just want that to be noted. So with this lesson plan here, we're going to take a look at this trapezoid. I have a split screen and I have an already drawn up trapezoid that I've drawn up on the left. So this trapezoid has all the elements of what defines a trapezoid. I've got my two parallel lines. This is a quadrilateral, meaning there are four lines, four corners. And I have this trapezoid fully defined by dimensions, controlling the size, and relationships between the lines and the construction elements being the y-axis and the x-axis. So I have the top line. If I look at the relationships on it, it is horizontal and it is parallel to the base axis, the base line. They are symmetric to each other based on the x-axis. The two angled lines are symmetric to each other based on the y-axis. The height is controlled by 100 millimeter, the base by 75 millimeter, and the top by 50 millimeters. The entire drawing has been sketched up in millimeter units. So when I go over to my right screen, I will start by drawing four lines connected to create a quadrilateral. So my first definition, the way I would define the top line is to make it horizontal. And then I will make the bottom line parallel to the top line. Now I will control the height with the dimension of 100 millimeters. And I will make the two lines symmetric to the x-axis. Now I will start adding some dimensions. I will control my base length with a dimension of 75 millimeters. Same as the trapezoid on the left. I will control my top line length with a dimension of 50 millimeters.
Now I will take the two angled lines and make them symmetric about the y-axis. So now I have a fully defined trapezoid controlled by two parallel lines, an axis of symmetry that they're both symmetric to, two angled lines that are symmetric to the y-axis, a baseline defined by a dimension of 75 millimeters, and a top line dimensioned to 50 millimeters. Now the trapezoid on the right completely matches the trapezoid on the left. Now to end this, I would exit out of my sketch and save my files. I would like to say thank you for your time in watching this video, and if you have any questions, I'd be happy to answer. Have a great day.